All right, guys, this video is to be used to help us as we use the PASCO Capstone software as part of our investigation into the acceleration due to gravity. So after you've captured your video and uploaded it to Google Drive, you're going to then download your video from Google Drive to one of the computers in the lab station. And then on that computer that you downloaded, you're going to pull up the Capstone software. So you can use the Capstone icon, which is here, or in the search here, just type Capstone and pull up the software. All right, so when you come to the initial prompting, go ahead and click on Video Analysis and find the video that you downloaded, which to your computer, which for me is going to be this guy right here. And again, just a reminder, this video is you want to record in 1080p at 60 frames per second. Gives us so far what I found to be the best results. And you really want to try and make sure that you launch the ball up in the air in the same vertical plane as the meter stick, which is used for your reference to set the scale. So once you have the video loaded, let's go over here. You can adjust what you want. We actually want the vertical position, which is the Y for object one, so we're good there. And in your horizontal position, your horizontal axis, you're going to want to use time. Now, the video software is already set up to start analyzing the data, and basically what we're going to be doing is clicking and tracking the location of the ball as it's in free fall or flight of the air. So you have to play the video, and that's why it's best to kind of crop the video before you upload it to the point right before it is released from the person's hand. So I'm going to play the video here just to get things going. I'll stop. I'm going to come back a couple frames. Okay. It doesn't matter if there was another frame right before. What is important is that you clearly see that the ball is no longer in the hand and there's space in between. This way, there's no chance for the person's hand to be still causing an additional acceleration on the ball. Remember, we're trying to analyze the acceleration due to gravity. Now, on the screen, there's a couple things. You have to actually set the scale, the calibration tool here, to the length of the meter. Okay, so at either point here on either end, you can grab these and adjust these, and it zooms in, and we're going to just hover right. It's a little hard to see, but right over the top of the meter. Let's try that again. Try that right there. And down here on the bottom, it's a little bit easier to see. Again, we're trying to grab the end of the meter stick there. Okay. You can see right here that the default for the calibration is a meter. If you needed to, if you had another object that was measured, you could change that height by clicking in here and changing that. But we're using a meter stick, make it simple for us. Now, you actually have the X and Y coordinate system here, and where you want the 0, 0 in your frame here to be referenced as it correlates to your graph, you can move this around. So you don't really want it to be on the starting point of the ball just because it makes it a little bit harder on where to click. But I would say maybe start from the hand as a good starting point. It's going to give you a graph that's right down here in the top right quadrant of your graph, your XY graph there. So you're already set up to go. What you can try and do, there's a little bit of blur even at 60 frames, but you're going to try and pick the center of the mass of the ball, of the blur. And by clicking to get started, it will actually progress each frame. And so again, I'm just going to keep clicking, trying to find the center of that blur. Again, what's important is that you're consistent in your approach. Now that it's starting to get up into that background, it's a little bit harder to see. And you can, if you'd like to, you can use this magnifying tool. So it magnifies the area around the cursor. So especially for me up in this white region here, it's a little bit easier to see. against the contrast of the painted wall versus the cabinet. Again, you're just clicking, trying to find the center, and we're going to try and mark the center location each frame. The center of the blur. Stay consistent. What's important is you're just consistent. I'm going to get out of my zoom here. And maybe one more click. All right, I think that's good enough. I don't have to go back into his hand. The point here is that we are experiencing only the acceleration due to gravity here in free fall, which is what we're trying to analyze. Now, I'm going to go over to my graph, again, vertical position versus time, and zoom in here. And you can see I actually went past my original coordinate system, which is fine. We're going to be looking at this data here. And again, for the position versus time graph, you're going to apply a curve fit. So up here is, this looks like a linear trend line fit. We're going to click on the little black arrow, and we're going to click on quadratic and click back in the graph. And what it's done now is applied a fit, a line to the data of all the clicking that I just did, of the position of the ball with respect to time. Again, only analyzing the vertical position. So any left to right or horizontal position, it's not what we're focusing on, it's just the vertical aspect of it. And I have this quadratic formula with A, B, and C here that you can use to analyze. And this is one of the equations you're going to want to look at and compare, see if you can glean any information from this with the new UAM, or uniformly accelerated motion equations, that you'll be learning about. So there, that is one of the spots they're going to want to capture. While we're here, let's go ahead and do that and capture the snipping tool here. So I can click on the snipping tool. If you don't see this on your tray, go ahead and just type snipping. It's part of Microsoft's tool, so it'll definitely be on your machine. And we're going to click new. And what this is doing is just allowing us to control what our screenshot is. So if I wanted to just grab this area right here, there you go. What it does is it actually copies it to your clipboard. And now, after you've, from the template that I provided you, you can pull this up. And in your video analysis section, you can just go ahead and Control V and paste it right in there. Now, it's a little hard to see. And maybe what we want to do is just, let's see. It's a little hard to see there. So let's go back to Capstone. And how about I just grab this graph right here? Again, let me go back to snipping and new. And then this time I'm just going to grab, including the icons, just the graph itself. See if that gives us a little bit better view for our report. Again, Control V to paste it right in. All right, now that's a little bit, it's a little better, okay? It gives us the ability to actually see it without having to zoom in. So there's my position versus time graph. I'm going to want to do the same thing for velocity. Again, with the trend line and the curve fit with the quadratic already on there, it kind of captures that right in that screenshot. I'm going to go back to Capstone, and this time I'm going to click on the vertical axis and change it from still object 1, but this time instead of vertical position, we're going to look at V sub y. In other words, the vertical velocity with respect to time. Now we're going to have to adjust because our data points are a little different here. Let's make sure we get our data in view, but I don't want a quadratic. I actually want a linear. So click off of the quadratic and make sure the linear is selected. And now we will get a linear fit to that data. By the way, while we're here, if for some reason you had some errand data that you didn't want to use, you don't have to redo the whole experiment. You can use this highlighter tool, and only the data that's in the graph, in the highlighted area, will be captured and utilized to develop a linear slope there. Okay, if I didn't want to use that, I can just delete that, and the linear slope equation will be applied to the entire data set if I feel like I have a good data set, which I believe it looks like we do. Can change my zoom a little bit here, and it looks good. I'm going to go ahead and grab another screenshot to add to my report, this time of just the velocity versus time graph. And again, it puts it on my clipboard. I'm going to go back to here and Control V, drop it in. Okay, so I have these two graphs here that are now part of my informal lab report that, again, this velocity versus time graph should be telling me something about the acceleration due to gravity. And it's another way for us to analyze and compare and investigate the acceleration due to gravity.